What if Pluto, that distant, icy dwarf planet, isn't as frozen and lifeless as we thought? In 2015, NASA's New Horizons spacecraft zipped past Pluto, revealing a world far more dynamic than anyone imagined. Among its jaw-dropping discoveries were giant ice volcanoes, cryovolcanoes that spew slushy ice instead of molten lava, hinting at a geologically active Pluto with possible subsurface oceans. Published in Nature Communications in 2022, these findings have flipped our understanding of this Kuiper Belt world upside down. Could these icy eruptions mean Pluto is a prime target for future exploration, maybe even harboring conditions for life? Let's dive into this cosmic game-changer, explore the science, and ask, what's next for Pluto's frozen frontier? Pluto's surprising cryovolcanoes, a new view of the dwarf planet. When New Horizons flew by Pluto on July 14, 2015, it captured images that shattered the idea of a dormant, icy ball. Southwest of Sputnik Planitia, a vast, heart-shaped nitrogen ice sheet, scientists spotted massive domes, some towering up to 7 kilometers, 4.3 miles, high and stretching 30 or 150 kilometers, 1893 miles wide. These weren't typical volcanoes. Named Wright Mons and Picard Mons, they're cryovolcanoes, erupting a slushy mix of water ice, ammonia, and methane instead of molten rock. Unlike Earth's fiery volcanoes, these icy giants extrude material like cosmic toothpaste, freezing instantly in Pluto's frigid -232 degrees Celsius, -387 degrees Fahrenheit, surface temperatures. Why is this a big deal? The region around these volcanoes, studied in detail by planetary scientist Kelsey Singer and her team at the Southwest Research Institute, has few impact craters, suggesting geologic activity as recent as 100 and 200 million years ago, practically yesterday in cosmic terms. Some scientists, like Singer, speculate these cryovolcanoes might still be active, reshaping Pluto's surface episodically. Could these icy eruptions still be bubbling beneath the surface, waiting to surprise us? How cryovolcanoes work on Pluto. So how do you get volcanoes on a world colder than an Antarctic winter? Cryovolcanism on Pluto involves internal heat melting subsurface ice into a slushy cryomagma, which then oozes through vents or fissures. Unlike Earth's volcanoes, driven by molten rock from a hot core, Pluto's cryovolcanoes likely rely on residual heat from radioactive decay in its rocky core. This heat, possibly trapped by an insulating layer, could keep pockets of liquid water or ammonia-rich slush mobile beneath the surface. The result? Domes like Wright Mons, which rivals Hawaii's Mauna Loa in volume but forms through multiple merged eruption sites, creating hummocky, undulating terrain unique in the solar system. The lack of craters in this region is a clue to its youth. Pluto's surface elsewhere is pockmarked with impact scars, but the cryovolcanic area looks freshly resurfaced, with bumpy, water ice-rich terrain. Singer's team estimates the volume of erupted material exceeds 10,000 km3, enough to fill Lake Superior several times over. But what's powering this activity so far from the sun, where heat should be long gone? Could Pluto's core be hiding more secrets than we thought? A subsurface ocean? The case for liquid water. Here's where things get wild. Cryovolcanoes suggest Pluto might have a subsurface ocean even today. Earlier studies hinted at a liquid ocean beneath 100 and 200 kilometers of ice, possibly sustained by heat from radioactive decay or past tidal interactions with its moon current. The 2022 findings bolster this idea as cryovolcanism requires a liquid source, likely water mixed with volatiles like methane or ammonia, to feed these eruptions. If true, this ocean could be closer to the surface than previously thought, making Pluto far more dynamic than its icy exterior suggests. Why does this matter for exploration? Liquid water is a key ingredient for life as we know it. While Pluto's harsh environment, low temperatures, thin atmosphere, and limited nutrients, makes life a long shot, the presence of a subsurface ocean bumps the possibility from impossible to slightly plausible. As Singer notes, any organisms would need a steady nutrient supply, and episodic volcanism could complicate survival. But the mere chance of liquid water has scientists buzzing. Game changer for future missions. The discovery of cryovolcanoes is a wake-up call for planetary exploration. Pluto, once the overlooked ninth planet, is now a geological hotspot in the Kuiper Belt, the solar system's third zone beyond the gas giants. New Horizons, the only mission to visit Pluto, revealed a world with mountains, glaciers, and nitrogen ice plains. But its cryovolcanoes steal the show. They suggest Pluto has retained internal heat for billions of years, challenging models of how small, distant worlds evolve. This makes Pluto a prime target for future missions, like a proposed orbiter to map its surface and probe its subsurface. What would a new mission look like? An orbiter could use radar to peer beneath Pluto's icy crust, confirming the ocean's existence and mapping cryovolcanic sites. It might carry spectrometers to analyze surface composition, looking for organic molecules or signs of recent activity. The James Webb Space Telescope, JWST, which in 2025 studied Pluto's climate and detected complex molecules on other Kuiper Belt objects, could complement such a mission by providing infrared data. Pluto's place in the solar system. Pluto's cryovolcanoes aren't alone in the solar system. Icy moons like Saturn's Enceladus and Neptune's Triton also sport cryovolcanism, spewing water or methane plumes. But Pluto's features are unique. No other world has domes this massive or terrain this hummocky. Enceladus's plumes, for example, erupt from tiger stripe fissures, while Pluto's cryovolcanoes form broad merged mounds. This uniqueness makes Pluto a natural laboratory for studying cryovolcanism and its role in shaping icy worlds. The discovery also rewrites Pluto's story. Demoted to dwarf planet in 2006, Pluto was once seen as a static, frozen oddity. Now, with its active geology and potential ocean, it's a dynamic world rivaling the complexity of larger planets. New Horizons principal investigator, Alan Stern, called Pluto the best for last, noting its geologic personality continues to surprise. Why this matters for exploration? Pluto's cryovolcanoes are a game changer because they demand we rethink exploration priorities. A subsurface ocean and active geology make Pluto a high-value target for studying planetary evolution and habitability. Future missions could drill into the ice, sample cryomagma, or deploy rovers to navigate the hummocky terrain. Such missions would test technologies for exploring other icy worlds, like Europa or Enceladus, where life is more likely. The public's imagination is also fired up. Social media posts on X in 2022 buzzed about Pluto's volcanoes, with some users joking about ice lava vacations. While not practical, the enthusiasm shows Pluto's allure. Looking ahead, Pluto's next chapter. As of September 10, 2025, NASA's New Horizons continues to send data from its extended mission, studying Kuiper Belt objects in heliophysics. But a dedicated Pluto orbiter, proposed by scientists like Singer, could unlock the dwarf planet's secrets. It would map cryovolcanic regions, probe for liquid reservoirs, and hunt for organic molecules, key to assessing habitability. JWST's 2025 observations of Pluto's haze and climate already hint at a complex world. A new mission could build on this, perhaps launching by 2030 if funded. The road ahead isn't easy. Pluto's distance means long travel times and high costs, and NASA's budget prioritizes Mars and the Moon. Yet Pluto's cryovolcanoes challenge us to think bigger. They suggest small worlds can harbor big surprises, from active geology to potential oceans. Could Pluto hold clues to life's origins in the outer solar system? For now, its icy volcanoes stand as a testament to the universe's knack for defying expectations, urging us to keep exploring.